I have been lucky to have worked on many broken Commodore 64s, and it has brought me lots of content on this channel. In fact, it was the Field Found 64 that really brought a huge number of viewers to the channel a number of years ago. Well, when I was handed this Commodore 64, I thought it would be pretty interesting to take a look at what exactly is going on with this one. Because over the years, I've had many Commodore 64s, and sometimes there are slight, small mods on them, like maybe a reset button or a switch. But I've never had an entire extra spacebar on the keyboard. So in this video, what I want to do is take a look at this machine and see what exactly is going on here and try to theorize on why someone might have actually modified this computer in the way it is. And if this machine is broken, then it's going to be a repair. And it's a bread bin and it's in rough shape, so it's almost certainly broken. So without further ado, let's get right to it. So the backstory on this machine is that I was up at VCF in Seattle and this was handed to me. And you know, it's always fun to take broken Commodore 64s because I know they're going to make interesting repair videos. But when I looked at this, I thought like, what exactly happened to this machine? So besides the aforementioned spacebar, which I might add is totally functional, I mean, at least you can push it, it feels normal. This machine also has some other mods on it, like this. I don't know if this is a socket or something else. My assumption is there are connections attached to that. I have not done any testing whatsoever, so I really don't know the condition of this thing. It might be missing all the chips for all I know. I can tell that it's got the motherboard installed since, of course, it has ports on the side and we have ports on the back. Oh, I did write something on the bottom here that this was donated by Chris Henkel. So thank you very much, Chris, for thinking of me and giving me this computer. I think there's actually another Commodore 64 that was given to me by Chris, but that other one is just, you know, bog standard, at least on the outward appearance. Nothing odd going on. Oh, yes, there is also a button on the side here, and it is a push button, a momentary, which we have to assume that this one is probably the reset button, just because that's in sort of the normal position of those types of things when you do that to a 64. Now you can see just by looking at it, this thing is quite grimy, but I think, you know, there's nothing on here that wouldn't clean up. We do have 3 broken switches, but I went into my spare parts and I was able to find the missing keys, plus new stems and springs, which are needed to fix this keyboard. So I should be able to get this thing at least back to working condition. Although I can tell you, I'm definitely not going to be removing this spacebar. Whatever it does, it's going to stay. Now, before I open this computer, we can actually see all the mods that are done to it and to see how the spacebar is actually hooked up. Let's just kind of think about why someone might do this modification. I was sort of racking my brain, started thinking about maybe this is for an accessibility reason. Perhaps the user of this computer, for instance, only had one hand they could use, and maybe that hand only had like 1 or 2 fingers on it. Well, say you only had 1 finger and you could definitely type pretty well on a computer. You'd be able to kind of get stuff done and write basic programs. But where it would be difficult is imagine you need to type a quotation mark or a $sign. Well, with 1 finger, if this were a shift key, the spacebar, you could actually push the spacebar and the number 4 key at the same time. And you would be able to kind of get all of these keys actually 1 through 0. Well, there's no shift function on 0, but 1 through 9 would all be accessible using this spacebar if it's hooked up as a shift. You know, there is the shift lock key. And I guess that's one thing about the 64 is it is extra accessible because I think the shift lock key, when you push that, it literally is the same thing as just holding down shift. And therefore, any of the keys that have a shifted function would be available to you. If you have an idea, before we actually open this up and see how it's hooked up, definitely comment down below and let's see if people are right at guessing how this thing is hooked up before we actually see how it's hooked up. Now, it goes without saying that we could open this thing up and whatever was done in here has been undone. Maybe there's like no wires at all hooking that space bar to the rest of the keyboard, or maybe that space bar goes to something else on the computer, like to the user port, and it was used entirely separately from the keyboard. We'll find that out when we open this up. Now, looking at the way this case was modified, we can definitely see this was just done by hand. I don't know how the spacebar was actually mounted, but at least the top cover was just cut out. Although that's a pretty nice sharp edge. That one, not so much, but this one definitely slightly crude. Now, one thing I did notice is that The regular spacebar oddly has, well, it's sort of notched, I guess you could call it, or that whole corner is cut off. Now, it still functions normally, so it has the stabilizer installed. And incidentally, so does this. This spacebar has its stabilizer installed, but I thought that was kind of curious about what's going on there. Maybe that was just by mistake when they took this thing apart, that broke, or maybe they had a wire or something that went down there, and that just gave it the extra clearance to allow that to function. Looking inside this case without opening it, I can see that there doesn't appear to be any kind of RF shield on the top side of the motherboard, but we can definitely see that there is one on the bottom side. So there's a little bit of the shiny stuff in the cardboard. Doesn't really tell us a whole lot. Someone might have worked on this motherboard, replaced a chip or something like that, and just thrown that stuff back in there. But we'll find out more when we open this thing up. All right, enough procrastinating. Here we go. I think the screws, oh, there is a screw in the bottom. Let's pop that screw out and let's see what kind of mods have happened to this 64. All right, here we go. Oh, good old crack. Oh, no, there is a shield still in here. Oh, the keyboard not connected. All right, let's see here. Oh, okay. Yep, look at that, everyone. So that space bar was attached, well, there's a switch. It's kind of glued on there, and it's attached where the shift lock key is. So again, I find that kind of odd. Wait, what is this? Oh, look, I didn't even realize. Okay, so this is a connector that is wired up, and it's hooked up to several of the wires on the keyboard. So we're gonna take the keyboard apart. I'll need to do that anyways to fix those broken stems, but it's like they drilled holes in the keyboard and then they attached these wires that went to that connector into, well, various spots on the keyboard. Very interesting. We'll be very curious to see what that's all about. Someone drew a circle right there for some reason. And this is just the standard Mitsumi keyboard. You can see like the bit of a sticker there, which is good because that matches exactly the parts that I have here to fix it. Looking in the actual 64 itself, oh, we are missing the SID. Aw, that's kind of sad. So our momentary switch on the side of the case is connected to ground on one side, and then this black lead is not hooked up to reset, which is normally something you'd take off the user port there. Well, it makes its way there to the CPU. Actually, that might still be reset. Pin 40 on the 6510. Ah, yes, that is absolutely just the reset line. It's interesting they picked it up right off the CPU there because I'm pretty sure it's also available on one of these user port pins. Looking at the rest of the system, we got kernel ROM in a socket. 6526s and everything else are not socketed. PLA, of course, is in a socket. And then down here, both 257s are in sockets. The DRAM is all in the board, directly soldered, and we have one Oki chip, and the rest are, I think, what is this, Panasonic brand? Can never remember. At least there is no MT. This brand of chip, 7406, I can't remember what this is. A little beta symbol. Is that a Brazilian brand? I'll have to ask my friend from Brazil, and he can tell me what brand that is. Everything else seems typical. Now, this is not unusual to have like one weird chip that was installed at the factory. It's just Commodore just would use whatever they had on hand, and occasionally they ran out of chips, so they would install sockets, for instance, for these two and the kernel ROM, and then when they had these in stock, they would populate them and then put it into the case. SID and the PLA was always in the socket, and the VIC is a 6567R9. This is an NTSC chip, which makes sense because, of course, this is a North American machine, and we can see the crystal 14.31818. That is the NTSC crystal oscillator. We can see the date on this is 1986, 24th week. That kind of implies this has actually been replaced. Also, the shield that was in here that covers this and a little bit of the heatsink compound is missing. Most of the ICs in here are from 1983, the ones that are soldered into the board. We can see that one is from 84. But this is 1983, 1982, and so on and so forth. So the fact that it's 1986 kind of implies that there was a failure at some point and someone swapped this out. Something else that looks a little suspect is this fuse. I don't think this is the right value. And it could well be that the VIC chip went bad and then it actually took out the fuse, because this is supplying the 12-volt rail via the voltage regulators down here. I read the markings on the side of this, and it appears to be a 2.5 amp fuse made by Desmon. Pretty sure that is not correct. Let me just check my other Commodore 64 board I just happen to have sitting right here. The fuse that's in this motherboard appears to be a 1.5 amp fuse. So at least if this is a 2.5 amp fuse, it's not wildly different, but I'm still going to put in this 1.5 amp fuse from that other board. I've removed that shield. Now, why don't we give this thing a test before I do anything else on here? Although I'm going to remove the VIC2 chip just in case there's a problem with the voltage regulation. I wouldn't want to damage this chip. Now, this particular board revision 25407, this is directly in the time period where MOS chips were, in my opinion, the least reliable. So most likely we're going to have a black screen with this thing. And a lot of times it is the PLA, but it can also be the ROM chips. Generally the CPU and the 6526s are well, they're less likely to fail, and at least these are pretty reliable. Someone in the past did write okay on the PLA though, using the pencil. So that's something. Power's connected, it's turned on. Let's check the output of this regulator right here. 12 volts, 12.13, that looks good. And then our 5-volt rail, 4.992, that looks good as well. So both of these are good. That means we are okay to put the VIC2 back in. Now, I've had lots of videos on this channel where I have gone to work on a computer and I'm like, oh, there's no video output, when it turns out that it is something to do with my capture setup. Now, this is unique for me because, of course, I'm capturing video to HDMI for the video. You wouldn't normally be doing this, right? You'd be plugging a monitor into this. So a composite monitor like this little one that's sitting right here is a really good thing, especially if you know the monitor works. But if you have a 64 that you say don't have a composite monitor, that you are sure it works, and say you don't have cables, a really good way to see if it's actually outputting a video signal is using an oscilloscope. That just kind of eliminates the possibility that you have a problem with your capture setup or your monitor and stuff like that, both of which I've had issues with in the past. So we're going to go with the oscilloscope method to just look at the video signal and just verify that it's there. And we could see by looking at it with the scope if there's even anything there or just looking at a black screen. So we look at the pinout of the VIC2, any VIC2, even the PAL variant's gonna have the same pinout. Our relevant output signals, they are pin 15, S Luma, sync Luma, and pin 14, which is the color output. So we'll start with pin 15, the sync Luma. We have this thing set for 1 volt per division. I don't know, that should be plenty, and let's turn this on. Okay, well, right off the bat, we can see that we have a black screen, and that's because you can ignore the fact that this kind of went up, but we see these pulses that are happening here. Well, these are the sync pulses, but there isn't anything else happening on screen. Now I'm just gonna change the time base. We're at 5 milliseconds per division. I remember at 60 Hertz, which is what this machine's running at, one entire frame is 16 milliseconds. But if we wanna take a look at the horizontal sync pulses, we've gotta turn up the time base. Now we're at 25 microseconds. What do we see now? There we have it. Okay, so let's zoom in a little bit more. So what we're looking at there, if the camera will focus, is we have the horizontal sync pulse. And then if you know your Commodore 64s, if you have a black screen, on the far left edge of the picture, you're gonna have a white line. That's what that is. So this confirms this machine 100% is just giving us a black screen right now. If there were borders and text after that little white spike there, you'd have some, more zigzaggy, jaggy stuff here that would indicate that there's actually an active picture. This is telling us that for sure it's not happening. Now, those occasional other pulses you're seeing on there, that is because this is the horizontal sync pulse that happens after every scan line. And then when the raster reaches the bottom of the image, there's going to be a vertical sync pulse and some vertical blanking stuff, and that's going to tell the monitor to move the scanning beam up to the top, and then it kind of repeats through the entire frame. So if you're on a 64S Luma output and you want to see the horizontal sync pulses, go to 10 microseconds, and then to go to the vertical sync pulses, you got to go the other way. So we zoom out, you can kind of see there's the vertical pulses there that are happening. If we keep going out to 2 milliseconds per division, there we go. So that's one entire frame. And so each one of these pulses is the vertical sync pulse, and that happens every 16.67 milliseconds, which is why we're at 5 milliseconds per division. Every little box on here is 1 division. So that's an entire frame. Anyways, this confirms for sure that we have just a black screen. Now, the thing is, there are a bunch of reasons why you have a black screen. I mean, I've talked about this a million times, but we could have a bad CPU, we could have a bad ROM, we could have a bad PLA with a bus conflict, we could have a missing clock, we could have a bad reset circuit that's keeping the computer in reset. One thing to consider about the Commodore 64, though, is that the video output signal, which we did see, and we saw sync pulses, that only works if there is a good clock going into the VIC2 chip. That's that 14.1 megahertz crystal, the oscillator circuit that's there, that's feeding into the VIC2, and then out of the VIC2 is the 1 megahertz CPU clock that goes to the CPU on this machine. So what I'm going to do right now is I'm just going to spend a moment to poke around and just see what I can see and see if anything's out of the ordinary on this thing. I'm just going to use this cheap oscilloscope here, and I'll come back when I find something that looks suspicious. Okay, I think I found a problem already, and of course it's with the PLA, which is totally not surprising, even though someone wrote okay on here. Reset was good, clock was good, voltage was good, I saw activity on the address lines that were coming out of the CPU, so everything seemed to be running on this machine, like it was trying to do something. Then I went to the PLA, and if we look at the pinout for the PLA, all the I's are the inputs and the F's are the outputs. The PLA's function is to take address line and other inputs and then select the appropriate chip on the board depending on what the CPU is doing. A lot of times you needed a whole bunch of discrete logic to do that in the old days, so the PLA was really to simplify the design of the motherboard. What happens when these go bad is the outputs, which should be high, and then they go low to select or turn on a chip, like say one of the ROMs or one of these 6522s. Well, where they fail is that the outputs get stuck where they're mostly low, like around ground, even though they should be going all the way up to, 4 or 5 volts or whatever like that, and they don't. So what happens is it ends up turning on multiple chips at the same time because one of the outputs, one or more of the outputs is stuck. So all you have to do is take your oscilloscope and then just probe all the outputs starting at F7 all the way to F0 and take a look at what those look like. So starting here at pin 10, F7, that's fine. It's up around 4 volts. As long as it's like over 3 volts, totally fine. You could ignore that stuff is there. That really doesn't matter. So look at the other pins, that's F6. What you can do is you can turn the machine off and on, just see if it does anything, but F6 looks fine because it's up around 3 or 4 volts, no problem. This is F4, no problems. Pin, it's a little hard to see because of the glare there. Now we're going to go to pin 15, F3, turn on the machine. Okay, so this is how it should look when it's normal. It's up around 4 volts, and these are the chips getting selected. So whatever this chip goes to, it's being turned on at those moments. And we go to the next one. This is pin 16, F2. This is incorrect. It's down around 1 volt. You can see it trying to turn off and on, like it's trying to select that chip. But from the chip that this goes to's perspective, it's going to be turned on all the time. So we have to look at the schematics to see exactly like what that goes to, but it's probably going to, oh, that one's fine. There we go. That's the one that's bad. This one is also okay. So this is probably one of the ROM chips as well. And the last one that is also on this PLA is that one, and that looks fine. It's really this one that's the problem. Let's figure out where that line is going. So that's the chip select line for the character ROM. You can see it looks like the signals we saw on there. There it is. It's the kernel ROM. So one thing we can actually do is we can take the kernel ROM out because it just happens to be in a socket. Now, it might not be in a socket on your machine, but in this one, it is. Now, this computer cannot work without the kernel ROM, except for one very important situation. If you use a cartridge that sets the 64 into Ultimax mode, which is basically an input signal that goes from the cartridge connector when you plug the cartridge in to the PLA, and that tells the PLA, hey, disable the onboard ROMs and then allow the cartridge to replace the ROMs. So now here's the problem with this particular computer. The PLA that's on here, it should stop selecting all the ROMs, so those lines that were dropping down to ground, that would stop when you put in Ultimax mode. Problem is the output on the PLA, the one that went to this kernel ROM, was bad. So even in Ultimax mode, this kernel ROM would still be told permanently to stay turned on, which means that this would be constantly writing to the bus, to the data bus. That creates a bus conflict, which would prevent this machine from doing anything, because anytime anything else on the bus, like say the cartridge or the RAM or anything, was trying to write to the data bus, well, this ROM chip would also be erroneously turned on permanently because of the bad PLA, even in Ultimax mode, and that would prevent it from working. So if you put in a dead test cartridge because of the bad PLA, the machine would still give you a total black screen. There's no way it can run any code while this chip is being told to turn on. So what I'm going to do now is we're going to do an experiment where I've taken this chip out and we're going to put in an Ultimax cartridge into this machine and see now if it's functional. In this unopened box, I have a care package from Matt Desmond, Factor of Matt, the maker of the DesTest cartridge, DesTest cartridge for the 64, which I've shown off a number of times because if I go over here to my little side table, I have the older version of the DesTest cartridge, DesTest Switch. There's actually an even older one, which might be this one. Here it is, DesTestMax 2024, Matt Desmond. So in the box, we have a couple cartridges and a letter written on like fax paper that I think this was actually faxed. Like it has a fax banner at the top. The letter reads, Dear Adrian, please find enclosed the following 2 quality Factor of Matt products for your C64 and C128. A DesTestMax Switch Select cartridge and an ACIA plus ROM plus RS-232 cartridge. The Switch Select cartridge has been preloaded with the most recent version of DesTestMax Switch Diagnostic, plus 5 other images you might find useful and fun. See the label. This, by the way, this package was sent to me back in June of this year. The ACIA plus ROM cartridge is fundamentally a SwiftLink 232 clone. SwiftLink being a serial interface cartridge from back in the day for Commodore machines. There's a clone, but with a PROM socket bolted on. This arrangement is ideal for DesTestMax SL, which has been included on the PROM. My plan is to release more PROM-based RS-232 related programs, though Max SL is the only one so far. The upshot here is that there are 7 free slots in the PROM to fill with whatever you like. Regards, Matt. The DesTestMax SL that Matt is talking about is a version of this diagnostic ROM that outputs over serial. Not something the 64 can normally do, but if you have a bad VIC or you're unable to connect your machine to a video display or something like that, this allows you to actually see diagnostic information over serial port. So we quickly take a look at Factor of Matt's, which is Matt's webpage. We can see the various cartridge versions available. So I didn't realize there's actually a DesTest VIC 20 now. That's pretty cool. All right, so starting with the original DesTestMax. What this does is it puts the 64 in the Ultimax mode, which is the original Max, Commodore Max mode that I talked about, where it disables the onboard ROMs, and it's able to test the first 4K of RAM. And when you have a failure, instead of the old dead test ROM, which would flash which bit it thought was bad, DesTest uses really comprehensive March U RAM testing, which is far better than the Commodore test. And then it also highlights which bits it thinks are bad. This is saying a bit 1 is bad, 3, and 5. Now, because you're stuck only testing 4K of RAM, that's not a comprehensive RAM test for the 64. So the Switch version of the cartridge has additional circuitry that after the first 4K is tested, it actually reboots the 64 out of Ultimax mode, so into normal mode, and then it is able to test all 64K. And that is the DesTest Switch, Switch being it's able to switch modes. So it first starts off in 4K test mode, just like the regular DesTest cartridge. And then once it is done with that, you'll see a reboot of the machine. It's very quick when it happens, and then it will give you the full 64K test, where it will use that March U RAM testing on the entire memory on the system, which, like I said, is really the most comprehensive way to do a RAM test, and is very similar to the way the Apple II dead test ROM is that I've shown off on the channel a lot, especially recently. And I'm loving the labeling that Matt has gone ahead and made for me, so Adrian's Digital Basement version. So we have DesTest Mini, DesTest KSP. These run in normal game mode, so not Ultimax mode. But then we have Switch, we have DesTestMax Switch version. Those are the ones I was just showing you the screenshot of. And then we have the Dead plus Diag FOM26. So I'm assuming this is the Commodore Dead test. And then in XROM mode, which is more like a normal game cartridge, we have Bradley Basic in Bank 1. Of course, we can select between those two right here. And we have Solitaire 2026. And this is a reset button. And then we have another cartridge here, DesTestMax Switch. So I think this is just the older version that doesn't have all the additional ROMs available on it. If you need to have a test cartridge in your arsenal, it needs to be very small, well, DesTestMax Switch is going to be the one. This is just the same functionality as this one here, Bank 0 Switch mode. So that would be this switch in the bottom position and Bank 0. And then the last thing in the box is the ACIA plus ROM. Now ACIA means that this, I think, has an actual like serial UART chip on here. Got to rip this bag to get it off. So there's our ROM with DesTestMax SL, the SwiftLink version of the ROM that outputs over serial. And this is the ACIA, so a Rockwell 6551, and that is the serial UART. And this is going to be the TTL, this outputs TTL, so TTL to RS-232 transceivers chip. So these two in combination outputs a normal RS-232 serial output from that connector. And because this is using a rather large EEPROM and there's a switch here and various jumpers, I have a feeling we can turn this off or maybe switch this into SwiftLink mode. And when you run it in SwiftLink mode, you plug this into the cartridge connector, and then we can run some terminal emulation software on the 64 and actually get pretty high baud rates. Commodore 64 and the 128, a lot of times people would use devices that would connect to the user port and output serial, but you were bit banging the serial through the 6526s. So I think you were limited to maybe 9600 bits per second, but more like 2400. But I'm pretty sure if you were seriously into BBSing, having a SwiftLink adapter or a clone like this was certainly the way to go for really reliable serial communications, especially at higher speeds. I am pretty positive that in this machine, with this ROM chip removed and nothing else changed, obviously we're missing the SID, but that doesn't matter, we probably should have a working system. And if the RAM is good, then this will tell us if we have good DRAM or not. I do need something to plug into here so we can look at the image on the capture device though. DesTestMax switch in there. Ah, we have other faults on this machine, obviously. Okay. I was so sure there's going to be a quick and easy fix, like, oh, it's just the PLA, take the kernel ROM out. Well, not so fast, Adrian, not so fast. Now, it is very repeatable if we hit the reset button. Colors do change quite a bit, though. But we're definitely having an issue with character generation, and that's odd, because the character generator should be turned off right now, which is this chip, and VIC-2 should be picking up the characters from the cartridge. But it doesn't appear that that's the case. Now, while this cartridge is in, remember the machine's in Ultimax mode, so we take a look at the output pins on the VIC-2. Remember the ones over here on the right side, they were actually going up and down, and they're not now. So that confirms we're in Ultimax mode. Now the next one here, this is going to be stuck low. This is the one that goes to this chip, so that's damaged. But that chip's removed, so that chip can't cause any issues for us. The third pin up was also toggling, and it's not anymore. So yeah, this really confirms we're in the Ultimax mode, and the fourth pin, also nothing happening. Let me quickly check the other outputs. This one is stuck around 1.1 volts. That's odd. Turn this off and on. Oh no, that one's working. But that output line, look at that. Look at that. Okay, wait a second. Check this out. So turn it on. This is an output. It's high, but the whole system is not executing code right now. So really nothing's happening. And when we just wait, look, it just falls and ends up at 1.1 volt. So this whole PLA is bad. I thought I was going to be able to get away with showing the system kind of working with the kernel ROM removed, but I just don't think that's the case. I think we got to just pop this chip out of there. So I don't confuse it, I'm going to definitely put an X on there. 100% it's bad for that bad output we saw going to the kernel ROM, so that condemns it immediately. So it goes without saying that you can replace your PLA with something like the GAL PLA, this little open source project from Daniel Mantione, but I have a few other PLAs available for us to use. There is the Plankton, there is the Platinum, and then we have the PLA Advanced. All of these were common and popular before we had the open source GAL PLA project. These CPLDs, though, are kind of hard to find these days, so the GAL PLA thing, to be honest, is just a better solution. But these do all work. So with that in there, let's take a look at these outputs. That looks normal. I can't remember which one it was. Was it the fourth pin up or the third one up that was doing that sagging thing? But it goes without saying that this thing is going to work properly. Okay, so that's one of the ROM chips. That's the kernel ROM, which of course is trying to be selected right now because we're not in Ultimax mode. And we have that one, which is pulsing right now. Anyways, the one that goes to the kernel ROM, which is this one, obviously is working correctly now. Let's pop in our kernel ROM, which hopefully is not damaged and is good chip still. And I am on the Luma output of the VIC chip. Let's turn this on. No cartridges installed right now. And there we go. That is a working Commodore 64. It is at basic right now. So at 10 microseconds per division, there's our horizontal sync pulse. That is the light blue border, the darker blue background, the light blue border on the right side, and then occasionally you'll see some jaggies. That is the text. So this machine is now working. This is not to say we don't have bad RAM, so why don't we put in Matt Desmon's cartridge here, and let's see if this thing has working RAM. Well, there we go. It is now working. So it's going to do the 4K RAM test. And here it just rebooted, and now it's doing the 64K RAM test. So this will take a little bit of time to run because the March test is comprehensive and kind of slow on the 64. Let me talk about what was going on there, though, why it didn't work with this PLA installed. Even though the bad output that was going to the kernel ROM was, eliminated because I took the kernel ROM out, I think there was just other internal problems with this chip. We saw the other output that was also getting stuck low. I don't even know what that goes to, but the thing is the DES test wasn't even working immediately, and it took a few seconds for that output to kind of drop down to 1 volt. So most likely there were just other fundamental problems inside this PLA. And that is completely not unexpected. And that's because this has 1984 date code on it. And this particular revision of the bread bin, these PLAs are notoriously unreliable and bad quality. Can't quite go as far to say that I recommend always just swapping out one of these PLAs in this version of the board if the PLA looks just like this, like it's got an 83 or 84 date on it, because sometimes these are okay. They're not always bad. But It doesn't take too much effort with an oscilloscope just to check the outputs, just like you saw me do, where you can start to see anything that looks suspicious on there that can indicate that the PLA for sure is bad. That's not to say I haven't had bad PLAs where all the outputs actually look good, because I have. Like there's other internal problems that keep it from working. But whenever you see one of the outputs that's stuck like it was on here, that right there immediately tells you the PLA is bad and there's no way it's going to work in the system. So therefore you should just swap it out and then continue your further diagnostics, kind of like we just did now. The corrupted video that we were seeing when we tried to run DesTest with the bad PLA installed, that could be caused by other chips on the board, like the VIC-2 could be bad and stuff like that. But like I said, when the PLA is known bad, just swap it out, then keep testing, because then you can try to find other problems knowing that it's not going to be a bad PLA like it was in this case. Okay, the RAM test passed. It started its next pass. I didn't catch it in time. I was looking away, but that means all of the RAM passes the March testing. So the RAM is solid. The PLA works. VIC-2 seems to work, as does the CPU. I know if I pop the cartridge out and we turn this thing on, we will get to basic because we saw that working on the oscilloscope. Yep, there it is. Looking good. I installed a SID chip, which I think works. It's in my little box of SID chips. So with that installed, let me just test to see if this SID actually works by running the dance party. Sounds like it's working pretty good. I think I'll put a tick mark. Once I hear a little bit more of the music, I'll know the SID is really properly working. Yep, good. That's a good SID. Because you never know with these older SIDs from that date range, 1984, same as that PLA that was bad, those fail all the time as well. I'm positive that these 3 ROM chips work as well. Plugging in the diagnostic test harness, I couldn't get this joystick connector into that port. I'd say that that is a problem. The pin is bent up. Let me try to solve that. Okay, a little spudger action later. I think that should do it. Yep, that fixed it. I should probably get a modified version of this diagnostic cartridge that skips all the RAM testing, because I've already done all that with DesTest. I don't need the crappy RAM testing this does. I just need to test the ports and make sure all the I/O ports and stuff like that are working on here. All right, so it says the interrupt is bad, which is the U1 chip, which is this one. I don't know if this actually matters. I'm going to take off everything else that says it's okay. I'm trying to think if the interrupt output on this was bad somehow, like how that would negatively affect the operation of the computer. You can tell there's a bit of a problem because look down at the bottom where it has the clocks, 00043 AM and 11111 PM. Well, those are the 2 time of day clocks that are held in each one of these. Obviously, the 11111 PM, that's wrong, because as the test runs, those clocks should count up. One is going to be AM, one is going to be PM, but it is stuck. My assumption is it's U1 that's our problem. Now, U1 is used for things like the keyboard and other stuff. The fact that the time of day is bad, is that going to have a detrimental effect on programs? Maybe, maybe not. But I think the keyboard is working. All the control ports are good. Therefore, this one, which is definitely handling the keyboard and the controller ports, there's no issue there. It is simply with that interrupt that's bad, and I guess the time of day is broken on it as well. So this chip gets an X, but this is bad, but bad in a way that maybe has no real effect on most programs. So with that said, let me just check out the various ROMs that are on Matt Desmon's cartridge here, the one with the switches on it. Just make sure everything works. Okay, yep, that's working fine. Bank 1, that should be Diag plus DedTest FOM 26. What is that exactly? Oh, DedTest Rev 781220 FOM 26 Special 2026 Edition. Updates by Matt Desmon. Well, that's cool. Let me go back and see what that was. Flash codes. So it's almost like Matt has taken the old DedTest ROM, but enhanced the initial phase of it, where it initializes the video mode, because normally it's just a black screen. It will flash the entire screen. And it looks like he has info here to tell you what the flash codes mean and which chip it points to. That's pretty clever, Matt. Very, very clever. Now, what I'm curious about is once it's done with this phase of the regular DedTest ROM, does it then use the switch hardware to reboot the computer and then run the standard diagnostic ROM, which is the one that uses the test harness? Incidentally, you can see at the bottom of the screen, this is also showing us that the time is wrong. And I think that actually shows up on Matt's DesTest switch cartridge. I just didn't notice. I can tell Matt's other modification to this ROM is that little bit of a I don't know what you kind of call it, border sparkle. That doesn't normally happen on this ROM, but it just helps you know that the ROM is actually executing code. If the system freezes, that sparkling goes away. Oh, and look at that. It did reboot into the normal harness version of the test. That is clever. So Matt, what would be amazing for this modified version of the ROM would be for it to run DesTest for the first 4K RAM testing and then reboot into this ROM, but modify to take all the RAM testing out. So just very quickly test to make sure that all the peripherals and ICs are working. Okay, so I'm in XROM mode, bank 0. This should be a version of BASIC, an enhanced version of BASIC. There it is. This is called Bradley's BASIC. I've switched over to bank 1. This should be Solitaire. Matt Desmon's music. Okay, let me turn the sound up. There it is. 2026 rules and 1987 rules. Okay, so ultimately I need a keyboard for this to work, and this keyboard that's for this computer, I still got to take it apart and fix it by replacing those stems because those keys are held down right now. So I can't test the rest of this game, but once I get this keyboard working, we will do that testing. And now I'll switch to game and bank 0, DesTest Mini. Is this DesTest Mini? I guess so. And then bank 1, DesTest KSP. Oh, keyboard tester. Wow, I am digging this, Matt. I didn't know about this. It's like an all-in-one keyboard tester. Okay, well, I have this plugged in, up, down, left, right, and then I have the fire button, and then on this thing, I have this A button as the up button. Let's plug into the other port. I know all the joystick ports are working because the other diagnostic ROM tested that stuff. Look at that. Neat. Okay, so everything works well on there as well. And I assume the XY is for the paddle inputs. I don't have a paddle handy to test that with. That actually uses the SID chip that digitizes those paddle inputs, some extra pins that are on there. Okay, well now we have an awesome keyboard tester. Thank you, Matt Desmond. Let me just fix this keyboard by replacing these stems and the keycaps so we can test this thing out. Okay, with all the screws out, I was able to swap out these 3 bad stems. And this is curious. I was desoldering the extra space bar, and they had it connected up where the old shift lock key was, but then they had the wire that was going to the keyboard kind of going through the shift lock, but it wasn't actually soldered. That one wasn't, at least. This other one was, though. So one was not soldered in. That just implies that the shift lock key itself probably wasn't working. Now I had to desolder those just so we could kind of get an idea of how this additional connector was wired up. Because some of the wires are connected to where the ribbon cable is that goes down to the motherboard. So we have white, brown, gray, purple, blue, green, yellow. This one is red, black, white. So if anyone's familiar with this particular keyboard PCB and knows what these connections would potentially go to, we just have to imagine that this allowed additional external keyboard to be connected up to this thing. Maybe like a numeric keypad of type. If we go along those lines, we're thinking about finances, maybe that spacebar was just a shift key to quickly allow them to enter in some of the extra things like parentheses and stuff like that, dollar signs, things like that. Although if they had an external keyboard, numeric keypad, why wouldn't they just added those functions, those keys onto there as well? Now there's quite a bit of kind of dirt in here, so while I have this off, I'll just clean this a little bit. Looks okay, I don't see any kind of corrosion, and that's a really good sign. Yeah, nothing over here on the F keys either. So just a tiny bit of IPA and just very gently wipe this. You really don't want to rub it too hard or it can like rub off the little contact points. So just a little bit, just to kind of clean off any kind of dust that's on there. Generally though, these Mitsumi keyboards, they are quite reliable if there's not like stuff spilled inside of them. All right, let's take a look at that space bar a little bit more up close. Maybe someone can look at this and recognize where this comes from, but someone has glued this on to the frame of the keyboard. There is one screw there, but it's not even in all the way. See, it's just sort of stuck in partially. It looks like maybe there were some additional screws at some point, but the glue obviously is holding pretty well. Oh, well, maybe not actually. And the key switch there, does anyone recognize what that might be? I don't want to put any extra stress on it. Of course, this was just cut out of another keyboard. I mean, it could have been another Commodore 64 keyboard, to be honest, but it wouldn't have had a normal key switch unless they somehow adapted this by gluing in a key switch onto the keyboard or onto the spacebar. That's probably what's going on. I'm wondering if I should try to add glue to this. You know what? I'm going to do that. I'd like to preserve this keyboard, so I'm just going to add a little bit of this UV resin glue stuff. Because I'm just going to reinforce this. I don't want this to come off. I've only recently tried this UV curable stuff, and I have to say, I absolutely love it. I feel that it works so well, it is so easy to apply, and it's really quite strong as well. Yeah, I mean, this stuff right here is already rock solid, so it does not move. That is not going to come off. So hopefully, if anyone wants to use this awesome shift key, they're going to be able to do it for 50 years, 100 years in the future, if this machine still works. Now with this thing all back together, one thing we can see compared to the 3 keys I just installed, look how shiny everything is. I think this keyboard got a ton of use. So whoever modified this with the shift key, they must have really used the heck out of this computer. And that's really cool. And obviously it probably wasn't ever this dirty. Maybe that came later when it was stored away. It looks like a sticker was probably right here at some point, but it's certainly curious to think about who did this modification and exactly why. Okay, let's test this out on the actual working computer now. All right, here we are up and running. Odd is look at the B time of day. It's now jumping between 0 and 0.1. Let's try reset on the cartridge. That works. How about reset on the computer? That works as well. Nice. So as you type, the keys or the letters turn black. So far, everything is working. Shift lock is on. How about the space bar? That works. That shift works as well. Both shifts are working. Oh no, the space bar. Oh, there we go. Space bar is a little dodgy, but it does actually work. So here we are in basic, and we can type, 5, and if I want a percent, I can just use this space bar. It feels kind of natural, to be honest. You want an ampersand? There it is. You want the brackets? There they are. You just hold that down. It's not a bad way to gain access to those extra functions. Now I'm curious if I poke my little jumper link into here, because that's a 2. Okay, so it looks like I'm able to get all of the numbers. Do I have everything? 1, 2, 3. I don't see a 5, but I think I haven't gone through every combination. But it looks like all the numbers are there, plus, minus, periods there, a few letters, stuff like that. So it pretty much confirms to me, at least, that this was for a numeric keypad. So I really feel like this was for financial use and not accessibility. So there would be a numeric keypad plugged into this port, and then for the functions like $, parentheses, stuff like that, they were using this space bar to get those keys. All right, there we have it, a repaired Commodore 64 and an unusual one at that. We figured out that this space bar is just a shift key and that this extra port here is most likely for a numeric keypad. So financial use, and this thing got used a heck of a lot. And we had a bad PLA that I was able to figure out if that was bad from my little cheap oscilloscope. Highly recommend you get something like that if you're troubleshooting a machine like this, because frankly, 99% of the repair work I do, I would be able to accomplish with something like this without any issue. I just use this bench scope for videos because it's a bit easier to use. Thank you, Matt Desmon, for sending me over your latest cartridges. I really like the keyboard tester you made and some of the other modifications you have to the other ROMs. I will definitely be using those cartridges in the future for future repairs of 64s. And yes, I have a little pile of broken 64s. So if you enjoyed this video, thumbs up. If you didn't know what to do, all the usual YouTube junk. Thanks to my supporters, thanks to my subscribers. And yeah, I'd love to hear your thoughts on exactly why this person modified this 64 in this way. Just so very curious. And I love seeing period correct mods like this. It kind of warms the heart. That's it. Stay healthy, stay safe, and I'll see you next time. Bye.